Use the definition to find the derivative of f of x equals 1 over 2x plus 1, then evaluate f prime of negative 3. The first thing to do is write down the definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x, all divided by h. The next thing to do is formulate what f of x plus h is. F of x plus h will be f of x replacing x with x plus h. F of x is 1 over 2x plus 1. F of x plus h will be 1 over 2x plus h plus 1. Subtract from that f of x, which is 1 over 2x plus 1, and then all of that is divided by h. Now we have the 0 over 0 indeterminate form, and we will continue to have that until we can get an h to factor from the numerator to cancel with that h that's in the denominator. Since the numerator has fractions, the first thing we need to do is combine those fractions through a common denominator. Before I actually do that, I'm going to take the first fraction and distribute that 2 in the denominator. It'll just make the denominator a little bit nicer looking for the common denominator. It'll be a 2x plus a 2h plus a 1, and then minus the 1 over 2x plus 1 all over h. So now we're going to start to make the common denominator out of those two fractions. It will be 2x plus 2h plus 1 times 2x plus 1. So I have to take that first fraction and multiply it by 2x plus 1 over 2x plus 1, a form of 1. So 1 over 2x plus 2h plus 1 times 2x plus 1 over 2x plus 1. There's my form of 1. And then minus, and then the second fraction, 1 over 2x plus 1, I have to multiply by a 2x plus a 2h plus a 1 over 2x plus 2h plus a 1, a form of 1, in order to produce the common denominator. And then this entire thing is divided by h. So now we will have limit as h goes to 0 of multiplying the first two fractions, the numerators, multiplied to be a 2x plus 1. The denominators we always keep factored, so while they are multiplying each other, we're not actually going to FOIL them out. We're going to keep them in a factored form. And then we have minus the second fractions multiplying the numerators gives us a 2x plus a 2h plus a 1. And then it'll be over that same common denominator that we're going to keep in a factored form. And then all of this is divided by h. So the next step is we're going to combine those fractions together since they have a common denominator. Just be careful with this minus sign that will distribute on every one of those terms in the numerator. So f prime of x will equal limit as h goes to 0 of 2x plus 1 and then minus 2x minus 2h and minus 1. Distribute that minus sign all over that common denominator, and then the entire thing over h. Now after combining the fractions, we may have some terms that can combine or cancel. We actually have a positive 2x and negative 2x. We have a positive 1 and a negative 1, and we'll get all of those to cancel. So we have limit as h goes to 0 of all that's left is a negative 2h over 2x plus 1, and then 2x plus 2h plus 1, and that entire thing divided by h. The next step, since we have a fraction in the numerator, is to take the fraction in the denominator and reciprocate it and multiply it. Well, the denominator isn't a fraction right now, but we can make it a fraction by putting it over 1. So we're going to reciprocate that and multiply it with the numerator. So that'll give us limit is h goes to 0 of a negative 2h divided by 2x plus 1 times 2x plus 2h plus 1 times the reciprocal of h over 1, which will be 1 over h. This will give us limit as h goes to 0 of negative 2h divided by, I'll just write the h first, but it'll be h times 2x plus 1 times 2x plus 2h plus 1. We still have 0 over 0, and we will continue to have that until we can get an h in the numerator to factor with an h in the denominator. Well, since that h in the numerator is multiplying a negative 2, it can just cancel with the h in the denominator. If we have more than one term in the numerator, we have to factor it, but we only had one term as negative 2h, and it can just cancel as is. And we can now write what we have left over. And we should no longer have 0 over 0, now that we've canceled that h in the denominator out. So we can take what's left over and just replace any h's with a 0. And that will give us negative 2 divided by 2x plus 1, and then 2x plus a 0 plus 1. Since we have 2x plus 1 times 2x plus 1, we can write that as 2x plus 1 squared, and there is your f prime of x derivative. The other thing being asked for is to evaluate, now that we've found this, f prime of a negative 3. So this will equal to negative 2 over 2 times a negative 3 plus 1 quantity squared. So this will be a negative 2 divided by 2 times negative 3 is negative 6 plus 1 and squared. So negative 2 divided by a negative 5 squared. Negative 5 times a negative 5 is a positive 25. So overall, we're getting a negative 2 over 25.